So when we hear production, what comes into our mind is output. That's what production is about. It's about the output that you're producing. And in order to produce this output, obviously you require certain number of inputs, and we have to figure that out. Okay? That how many inputs is going to help you produce how much output. Now, in your inputs, we've already done the four factors of production that you have. What are they? The land, labor, capital, the enterprise. The combination of these four will help you produce a certain output. Now, usually, what corporations do who have a very large scale manufacturing, they have certain algorithms and softwares which helps them with the idea that if you want to produce X number of cars, let's say, so these are the number of inputs, the land, labor, capital, enterprise you will need. Okay? So there is a production function for it, is what it's called, a production function. A production function is sort of like a relationship between output and the inputs employed in a given period of time. And we've seen this is how the equation looks like. A production function, यानी वो f of x जो होता है basically. What this is telling us is how much maximum quantity of a good you can produce when you have X number of land, X number of labor, X number of capital, and X number of enterprise. And a blend of this, a combination of this, is going to help you suggest what is the maximum quantity you can produce. I hope it's clarifying. In the short run, obviously, you will have some fixed factors. Usually land and capital are the fixed one. Land, capital, and enterprise are the fixed one. Labor is the variable one. And in the long run, all of these are going to change. So let me clarify the time periods in economics. It's very different from accounting, in which short run is like less than a year and long run is more than a year. In economics, your time durations short run is, and this is exactly what you're going to write, that you have at least one FOP held constant. At least one, all right? And usually it is capital ya land, okay? I don't think there would be any case in which labor might be your fixed one. Very highly improbable. Long run is the time duration in which all FOPs are variable, except for one thing, except for the state of technology. What does that mean? State of technology. State of technology is about like you can't change the software or the machines and go to a newer model which is more productive. You can increase the number of the same machines that you have with the same productive abilities. You can't move on to something new. So if you have like a diesel generator, you cannot move on to a more sophisticated, let's say, an LNG or a nuclear based generator or something. Same state of technology. And in the very long run, all FOPs and the state of technology are variable. So everything can change. With this knowledge, you can do one of the MCQs if it comes about. Take care, you get yourself 1 mark for that. But right now we're discussing short run. So you at least have to have one fixed factor. So There's an example right here. I hope you can see it on your screen. What is this example about? It's from the notes. So when you're reading the notes, you can come across this. And there's a proper, like, full explanation of it as well. We're talking about a car wash. Now, those of you who might have seen, experienced, or seen it in movies, it's I'm not talking about like a local car wash. I'm talking about like a foreign car wash, in which they have this one particular building with machines inside and people managing it, and it's like 70-75% automation, and then 20-25% uh, labor, which does some stuff over there. So based on the table, this is what we have: the number of capital, it doesn't change. So this is telling me we are in short run. Labor, on the other hand, when I had zero labor, my total product, the number of cars that we're washing, is zero, because without labor, tala laga hua hai, nobody's even running it. So no car wash that day. As I increase the number of labor, the number of cars washed is going up. Actually, it can eventually like fall down also. That's even possibility at like later number of labor. We're not discussing that right now. Our main discussion, if I was to plot this about my total, this is how it would look like: the total product and the quantity of labor. So if I was to plot it, this is how it would go. First, at zero labor, zero output. And then my first labor helps me produce about 30. With two labors, I go up really fast to almost 90. And at my third labor, it sort of like starts to slow down after that, almost till my sixth labor. This is how my total product looks like. It can eventually fall down also at later numbers. But over here, the numbers right now is not suggesting any of that. So at 6, this is what's happening. And at about 2, my speeding process just stops. Okay, so that's the idea so far. That's how the total product is going to look like. Then MP represents the marginal product. Really important that you know what marginal is about. Marginal is about one extra unit or one extra labor that you hire. You can even say this is like marginal productivity of labor. How do you take this out? Well, there's a formula which is change in total product over change in quantity. How do we figure it out? Let's look. When I increase my number of labor from 0 to 1, my total product went from 0 to 30. Now, the way this works is that I have one big car wash. This first person comes in, the entrepreneur and the labor also, probably, who's managing it. Both roles he has. So he comes in and he opens the shop, turns on the cash register, client comes in. Now he alone has to manage the admin office with cash register, stocking of things. If any supplier is coming down, he has to deal with them. While there is like cars are getting washed manually, by the machines, but once they come out, they have to dried up and small minor details have to be done by people. So he has to deal with that also. Too many responsibilities for one guy to handle. So what he decides is, let's get one more person. And when he gets one more person, his total product goes from 30 to 90. And what that means is that the second person was responsible for an addition of 60 cars. Now, why is that happening? The thing is, when you hired the second person, he enabled a system to come into play where one person was managing inside while the other person was just continuously drawing up the cars outside. And when there was no one on the cash register, probably this guy also goes and helps them out. So they were able to clean a lot more cars as a result of this proper system coming into place. Okay. In fact, if it's like a big car wash, maybe third, fourth, fifth, and your marginal product might have gone from 60 to maybe 90 to 120 to 180 and still kept on going up. But for our exam and limitation purpose, when you hired your third labor, your total product increases from 90 to 130, suggesting that the increase just happened by 40. What has happened? Your MP starts to go down. Your total product is still going up, but because of the fixed factor constraint, maybe there is not much responsibilities for him to take. Maybe what's happening is that three people are waiting for the cars to come out so they can dry them, but the speed at which the cars are coming out is much more slower. So two people can manage it much more effectively than the third guy. So you probably don't need that third guy. You can increase the number of cars altogether, but it's just that the system is slowed. Maybe if you had one more car wash, these three people collectively could have done a lot more higher productivity. So anyhow, so all production processes face this issue, and you keep on doing, you get 25, you get 17, and it gets 13. So if you look at your MP, first it goes up till the second labor, and then it starts to go down. So if I was to plot it, this is how it would actually look like. The MP would go up, okay, till the second labor. This is also called increasing marginal product. Okay. And after that, MP is positive side, but it's going down till it hits 0. And after this point, it actually goes into the negative. So when you have an increasing MP, your total product will be increasing at an increasing rate. When MP is falling but it's positive, your total product will be increasing at a slower rate. When MP is 0, TP will be at its maximum. And when MP goes into the red line, your TP starts to go down. All of this is already dealt with in the notes. If you want details, you can go and see the lectures, which I've already suggested you should do. As far as average goes, AP is for average product. On average, how much per person is cleaning. And the formula for that is total product divided by quantity, straight, no change. So for example, 30 cars, one labor, this one guy is cleaning 30 cars per day. Then you have 90 cars cleaned by two people, 45. And then its average starts to go down. And this is how the number looks like. And in my graph, this is how the average would go, something like this. Hits the highest point on marginal product, and then average starts to go down. This is how average and marginal graphs basically looks like. We have done this relationship between average and marginal before. Our relationships were, like if I was to break this line down like this, at these quantities of labor, marginal is on the higher side than the average over here. Marginal is up here, average is here. So as long as the marginal product is greater than average product, we say average product is going to rise. At higher quantities, MP is lower than average and it's going to cause the average to fall. And we can see it right here. Marginal is below the average, so average is going down. And at this peak point, your marginal product is equals to the average, and so your average is at its maximum. So these conditions you need to know uh, by heart for essay purposes and all. And that's how our diagram basically looks like. It's there in the notes. When MP is going up, it's increasing marginal product. When it's coming down, it's diminishing marginal product. Average hits the peak, starts to go down. Another key thing that I want to mention over here is this turning point, which is happening at my second labor. When MP is turning, this is the law of diminishing marginal returns or law of diminishing variable proportion. Same thing, okay, just different names. ये तुम्हारे short run के दो concepts हैं, which is that when you add the variable factors and the fixed factors, initially your marginal product experiences increasing marginal product. After it hits the peak, that's your law of diminishing marginal returns or variable proportions, and then it starts to go down like this. So in the short run, you have three costs you have to deal with: fixed, variable, and total cost. You probably have gone through this in business studies and O-level economics. Fixed cost are those which doesn't change with level of output. Okay. Variable changes with the level of output. Usually it actually has a proportional, not proportional, but the same direction, positive relationship. When output is zero, variable cost will be zero. But with fixed cost, when output is zero, you will have to pay certain costs. And total cost is just an addition of your total fixed cost plus total variable cost. It's the total cost that you're dealing with. It has both explicit and implicit cost in it. In fact, I'm going to be discussing more on this tomorrow, but just to mention right now, in these costs, we have both explicit and implicit. Explicit is the monetary costs that you have to pay for. Okay, the costs that you have to deal with. Like in a car wash, it could be the labor salary, it could be the rent that you have to pay, maybe the interest to the bank, वगैरह वगैरह. Implicit cost would be the opportunity costs. For example, the owner could have put the money with which he started the car wash, he could have put it in the bank and earned interest on it. So he's foregoing that. Or he could have gone somewhere else and worked. He could have earned some money over there. That's also his opportunity cost. So we will include both of them in our cost structures, both explicit and implicit. Accountants, on one hand, only takes the explicit. They are not interested with the opportunity cost, but economists wants to make sure that every resource that is being used, whether you pay for it or not, has an opportunity cost involved. So you should at least get a return, at least to that level. After that, you have average fixed cost, which is total fixed cost divided by the quantity. So if, let's say, your rent is $75 and you have only one car that's coming a month, so that $75 ka rent is gonna fall on one car. So the fixed factor of cleaning the car would be $75, which is quite a lot. You can't charge that much. You'll probably go into serious loss. Average variable cost, on the other hand, is total variable cost divided by quantity. Average total cost or average cost is what they use most commonly, is total cost divided by quantity. And then lastly, you have something called the marginal cost. The cost of producing one extra unit, which is change in total cost over the change in quantity. Now, the thing with marginal cost is it's about the change in total cost. And what we know is that total cost changes because of fixed and variable. Now, fixed doesn't change. So if there is any change in total cost is actually happening because of the variable cost, because this remains the same. So in another way, you can actually use this formula as well without any doubt. That is change in variable cost over change in quantity. That's even fair to use. But I would suggest for your essay purpose and all that, mainly use this one. So let's look at the numerical. A little overwhelming chart, but let's take a look at what's happening here. So it's short run, you have a fixed factor. We're not mentioning it here, but your variable factor is the labor. As you were increasing the labor, your output was increasing. The number of cars you were cleaning were increasing. It's the same spotless car example. Fixed cost is $75 and it doesn't change. It remains constant. Variable cost at zero output, variable cost is zero, and as the number of cars increasing, your variable cost also goes up. You add these two together and you get yourself the total cost, which is also going up continuously. Now, marginal cost, how we've taken it out is marginal cost has a formula, which is change in total cost over change in quantity. So change in total cost is 75 to 135. That's about 60. And you divide it by change in cars, which is 30. So I get my marginal cost as 2 per car. So from my first 30 cars, to clean every car, the marginal cost, the addition in the total cost or the addition in the variable cost, you can actually do it through this also. Look, variable cost 0 to 60, so 60 divided by 30, you're getting the same results. It's not happening because of this, because this doesn't change, so it has nothing to do with it. So the additional, for every additional cars from 0 to 30, for every car I have to add a little extra cost of $2. It could be because of the additional cleaning utilities that I'm using, or cloth I'm using for every car, a new cloth I'm using, or a freshener or something I'm adding. So that's my marginal cost for it. After that, for another, now I have 60. So let's look at the change in the total cost is also 60. So 60 divided by 60 gives me 1. So this is how I am dealing with this. All right. So change in total cost over change in quantity, I get my marginal cost. When I plot for this marginal cost, it's going to look like first it's going to go down and then it's going to start going up again as the number of cars increases. Average fixed cost, on the other hand, just simply take 75 divided by 1, 75 divided by 30, it's 2.5. 75 divided by 90, 75 divided by 130. So the more cars I clean, my average fixed cost just keeps on going down, down, down. Average fixed cost can never go up, by the way. It will just keep on going down. All right. If I decide that my fixed cost is going to change, so that can only happen in the long run, that your fixed cost can go out and disappear or something. But otherwise, it can't really change. My variable cost falls at first, average variable cost falls at first, and then it starts to go up. It happens. And that's exactly what's going to happen to your total cost also, because how are you getting your total cost? You're just taking these two values, you're adding them up, and you get yourself the average cost or the average total cost. When we plot for these, this is how your variable cost and total cost looks like. In O levels and in business studies, you are probably making the straight lines, but in economics, we don't work with the straight lines anymore. This is the total variable cost that we want to talk about. The distance between this and this measures, like for example, if I was to take out total cost minus the total variable cost, I get the distance, which is total fixed cost. So this gap right here represents the total fixed cost. It's going to be of the equal size total fixed cost. Okay, it's just going to jump parallel upwards, and this line is showing that this is where the fixed cost really is. So if they haven't given you much information, this is how you recognize that whenever the total cost is starting from this line. I have seen questions in which your total cost is actually, they've given you a curve like this, starting from zero, and it's going like this, and they're saying this is the total cost. So tell us something about the fixed cost. Well, there is no fixed cost for this business. This is a business without any kind of fixed cost, if that was the case. Okay, so that will not necessarily happen. But once you have this is how your average and marginals will look like. Your marginal first comes down. What you have mainly done with me is we've been talking about the Nike shaped sign. So we've been dealing with this kind of marginal cost curve. But technically with numbers, this is how it actually looks like. First it falls down drastically, comes down to the lowest point, and then it starts to go up. Just the opposite of your MP curve. If you remember, just a while ago, we did our MP and it was just like the opposite of that. Let me zoom out and show it right here. It's exactly the same, and the example is exactly the same also. So we have a good similarity over here with over here. Actually, they are kind of like a mirror reflection. Exactly where this will be at its highest, this will be at its lowest. Anyhow, so, and then on its way up, MC is going to cut average variable cost at its minimum point, and then again on its way up, a marginal cost is going to be minimizing average cost at its lowest point, and then it's just going to follow through. And in perfect competition, we talk about the supply curve and how it looks like. We'll talk about that in another chapter. But this is how it looks. Now, key things for MCQ purpose is this in your short run curves. ABC, point ABC. When the total cost curve is going up and it has a curve at which it's turning, you'll have the same curve at the variable cost also, the turning point in your total cost. That turning point is where your marginal cost is going to be turning as well. Okay, the shape. They're actually like marginal and total are actually linked together because the change is through which you get the marginals. So this is one thing you need to know. The turning point of the total is the lowest point of your marginal cost. Another thing is point B. Let's take a look at point B. What is point B showing? This dotted line right here is basically showing you the gradient of this point. इस पॉइंट का ग्रेडियंट क्या है? इस पॉइंट का ग्रेडियंट है चेंज इन y ओवर चेंज इन x. Change in y over change in x. Change in y is the variable cost. So इसको change in variable cost कर लो because y2 minus y1. This will give you y2 minus y1. Variable cost में change. Divided by x2 minus x1. So since we have quantity over here, this is about the change in quantity. And when we do change Uh, no, we should not be doing the changes. Sorry, my bad. The reason why we're not doing the changes over here is because मैं point B का निकाल रहा हूँ. So for point B, at this point B, this is your variable cost and this is the quantity. So basically I'm just doing variable cost divided by quantity and I will get what is the average variable cost at this point B. So when I do this, what happens is this dotted line right here is a tangent. Tangent matlab it's just a touch and go point. And when it has a touch and go point, that means your average variable cost will be at its lowest point as well. Okay. The same with point C. With point C, what I see over here is this is my total cost, the yellow line, and this is the quantity. So at point C, when I take the total cost and I divide by quantity, I get my average cost. And at this point C, where you are just tangent, your average cost will be minimizing. And so through dotted lines, we are showing that this is exactly what's going to happen. जहाँ पे tangent होंगे. If it was non-tangent, then you would not be on minimum, you would be slightly on the left or the right for a non-tangent situation. Okay. Now, other than this, sometimes in the MCQs, and we've done these MCQs, they have shown that your line is going from here, this point. When I make the origin over here, basically, and I make the lower part disappear, that means I've taken out the fixed cost because this is what the fixed cost was. So if I'm making my dotted line from here and I'm trying to look for the tangent, what's really happening is that from my total cost, I have eliminated my fixed cost by starting from here. My fixed cost, I've just taken it out. So from the total cost, when you subtract the fixed cost, you're left with variable cost. So this diagram right here, by starting this dotted line from here, I have eliminated the fixed cost and now this curve has actually become my variable and it's tangent, and you can see right here, it's actually meeting the same variable cost ka minimum point. So again in MCQs you will see a dotted line coming like this and getting you a tangent. So make sure in exam you have the ruler with you. Without that you would have troubles. So that's pretty much the important stuff about the short runs. Now in your long run, where all factors of production are variable, we have two concepts that we discuss over here. One is called return to scale, in which we're going to look at how much output is being produced by the inputs that you're putting in. Okay, so if you increase your input by 50%, what will happen to your output? Will it increase by more than 50? Will it increase by 50? Or will it actually increase by less than 50%? And we will be discussing economies of scale and the diseconomies of scale, which is about your total cost divided by quantity. So basically it's about your average cost. What's going to happen to your average costs in the long run, where all factors of production are variable? So these are the two concepts. In the short run, you have law of diminishing marginal returns and law of variable proportions. In the long run, you have these two concepts. So let's work with them. First, something called increasing returns to scale. If you just settle with this point clearly in your heads, you can save a lot of trouble in the MCQs. constant return to scale. And lastly, you have a decreasing return to scale. Basically, what's happening is if you double your input and you get more than double, okay? So, for example, the percentage change in output is greater than the percentage change in input. What's going to happen as a result of this? If you increase your input by 50% and your output is increasing by, say, 100%, you have a return to scale of about 2. And what that 2 really means is that for every 1 input, you are getting 2 output. That's an increasing return to scale. That's a very favorable situation. In fact, from the cost point of view, your average cost is going to go down. Second case is telling us that your percentage change in the output as a result of percentage change in input is exactly the same. You increase input by 50%, output increases by 50%. Your average cost is going to stay the same. It's not so bad also. But lastly, your change in output is less than the change in input. So you're putting in 50% more resources, and as a result, your output is increasing by just 30%. So that will cause the cost to actually go down, average cost to go down. Unfavorable situation. Okay, so when we're looking at from the return to scale point of view, this is our way of looking at it. Let's take a look at a long run average cost curve. This is how it looks like, an LRAC. As output is increasing, first it falls down, then it becomes constant, and then it starts to go up. Economies of scale is that when quantity is going up, average cost is going down, and we can see this right here. In fact, at this point, we can even safely say that you are experiencing an increasing return to scale. That's exactly what's happening. After that, your quantity is still going up, but your average cost is the same. It flats out. This is also known as constant return to scale or constant economies of scale. These are words which are interchangeably used, so please don't get confused that they haven't said anything about economies of scale, but they have given increasing return to scale. They mean the same thing. And lastly, output is still increasing and average cost has started to go up. This is known as diseconomies of scale, or it's the same thing as the decreasing return to scale. So this is how your LRAC looks like. It's not always going to be falling down. It will eventually start to go up. Now, with the economies of scale, when the essay comes, you should know your internal and external economies of scale. I'm not going to deal with them right now, but as far as your internal goes, obviously internal ones are the one that the business assumes certain steps and decisions which benefits them in terms of lowering their cost. And in internal ones, we talked about like the bulk purchasing, we have spoken about financial economies of scale, there is technical, there is managerial, risk bearing, so many, marketing, वगैरह. These were the internal economies of scale. Then you have diseconomies of scale as well, which is to mainly do with labor diseconomies of scale. They get less motivated and their productivity starts to go down. Or it could be communication. Business becomes too large, communication channels become too lengthy, and your cost starts to go up as a result of that. Okay. As far as external goes, external not just benefits the firm, but it also benefits everyone in the industry. And we said it could be because of training provided by government. So everyone is going to, all firms are going to benefit. Or something like infrastructure improvement, okay, which can include transportation, it can include communication. So something which benefits everyone and not just one single firm. Right. And then इसके अंदर भी external में भी diseconomies हो सकती हैं, like too many firms in one place, pollution, traffic congestions, and uh, land prices going up, and all of these sort of things. So last thing about the LRAC. LRAC is the lowest most curve. Production always takes place in the short run. Long run shows the planning of the business. Because in short run, you always have a fixed factor. You were working in one factory with X number of machines. Labor, you were increasing and decreasing, and this is what your average cost was like, until you decided to move to do an expansion. The moment you did an expansion, you moved on to your second SRAC. You further expanded, you moved on to third. Further expanded, you continuously moving on. And this LRAC shows you the overall planning of the business over whatever the amount of years were. And so LRAC is in the making, while SRAC is always there in the short run.